wonderforce.com.
Tinggi-tinggi tiang telekom. Assalamualaikum. We are from Group 7. Today we will like to present our group project. This is FM transmitter and receiver. First of all, we will like to introduce ourselves. My name is Muhammad Zain and this is our group.
My name is Nolena binti Nordin.
My name is Siti binti Syamsul Ahmad.
My name is Nur Azura binti Samsudin.
My name is Syarah Syarah bin Ayub.
We would like to start our first presenter. This is block diagram and circuit diagram of the transmitter.
Today we're going to present the FM transmitter. We will be using the IC KT0803K. So as you can see right here is a crystal filter that used to overcome the fluctuated in the graph to make the graph become more stable. And we proceed into this KTM property frequency synthesis and FM modulator. And this is a RF power amplifier that used to amplify the signal and become more bigger. This is the RF out. This is the FM modulator output. Will be bring out into the antenna. Then we can find the output signal for the oscilloscope through here. Okay, as we can see here, right now this is the ADC. ADC is a function as analog digital converter used to convert the audio into a digital signal. Okay, and right here is a I2C which lead to the SD and SCM as a function as a microcontroller unit that can control the frequency channel, which is can help to control the KT0803K as a slave. Okay, that is for all for my presentation.
Okay, this is FM module. We use KT0803K because of what? Because it has low frequency, which is 70 MHz until 108 MHz. It also can produce a low voltage from 1.6 volt until 3.6 volt. VCC is connect to 3.3 volt, but we don't use 3.3 volt. We use 4.5 volt because 3.3 volt can produce a weak signal. Okay, then ground, connect to ground, and then antenna we use for transmit signal.
Okay, this is a block diagram for FM receiver. Okay, receiving antenna is received from the FM transmitter. Okay, first block is RF section, which is receiver frequency section. And a receiver frequency section means they carry the signal from the transmitter, and mixture and local oscillator is a mixture to change of the frequency of a signal. After change the frequency, it's go through to the IF amplifier and limiter, which is this test is used to raise signal level in a radio at the frequency that we want. Intermediately to the higher radio frequency, which is RF signal from the antenna, and the lower baseband audio at the receiver is covering. And then after IF, it's convert to FM detector. FM detector consists a tune circuit where the center frequency is tuned to the frequency slightly offset from the carrier to the signal. After signal is carrier, the emphasize network is to compress the signal to AF amplifier. This block diagram AF amplifier is power electronic audio signals that convert the signal from the radio receiver of electric signal and then go to the loudspeaker that from the FM receiver to the load as the frequency that we carry from the transmitter to receiver.
Okay, I will explain about this circuit. This circuit name is FM receiver. As you can see from the TRA5767, this function is low voltage fully integrated intermediate frequency, that is IF. So This is function will receive module operate in 12C protocol using pin 3 BUSM mode. Okay, from pin 3 grounded and we had used 12C protocol. So from module TEA Arduino, so module TEA, from module TEA, data pin go to the A4, the clock pin to A5. From module TEA, pin 3 and pin 6 will go to the grounded Arduino, and pin 7 and pin 8 will go to the Arduino output of left and right channel.
This is a transmitter circuit that we construct. This is a handphone that we set the signal. This is Arduino Uno. This is KT. This is LCD Nokia that we tune the frequency to the receiver circuit. This is the receiver circuit that we construct. This is Arduino, and this is crystal LCD, and this is TEA, this is LM, and this is speaker.
Okay, as you can see here, this is our waveform at the receiver. So for the channels first, for the first channel is this is the input receiver, which is we get here is the sine wave. For the output receiver is we got the sine wave, but it's not smooth like the input, because here we have the voice. We have the voice interferes in this waveform, so that here as shown as the voice waveform. So starting from design the circuit simulation, and from after the simulation is coding and the design circuit, we actually have difficulties or problems or challenges in doing this. So first of all, our challenging is in the simulation part, which is we cannot simulate the two Arduino at the same time in the Proteus. We use the Proteus software for the simulation. So to simulate these two Arduino at the same time in the Proteus, we cannot give it that. So after that, we have a problem in the coding, which is for the transmitter coding, FMTX, which is we use the KT0803K. This KT0803K does not have the latest library for the latest version of Arduino. Next is a circuit. That we design actually is not suitable for the module of receiver, which is in the receiver part we need to add on the LM386 circuit, 386 module, to amplify our signal that we receive from transmitter. So next is jumper wire. Actually, for the jumper wire, we actually give an advice to make a own jumper wire, because the jumper wire at the shop or the electronic shop is actually have some problems, which is once the jumper wire is on the vibrate situation, they can broken. So your connection will be interrupted. So after that, for the last part is the waveform. Waveform in waveform part is actually for the first test is the 1 kHz test tone, which is why we did this 1 kHz test tone is we want to make sure that we transmit the actual frequency to the transmitter to the transmitter circuit that we produce. so that if the oscilloscope give the 1 kilohertz test tone, which is mean we actually produce the same frequency, that means our circuit is success. So for the waveform, I think that's all the challenges. Okay. Thanks to watch our video, and thanks to give our opportunity to perform the circuit and know how the circuit is actually function. So here's we would like to thanks to Dr. Shahri bin Muhammad Shah that actually teaching us in electronic communication system, and wish us luck in final exam.
Thank you.
Thank you,
Thank you.
Doctor. Bye.